Hello everyone. Today we're going to do buildings with an ocean view, which is LeetCode problem 1762. This problem holds a place in my heart since I live in San Diego and I wish I had a building, an apartment with an ocean view. Anyway, it's a medium problem stating there are n buildings in a line. You are given an integer array heights of size n that represents the heights of the buildings in the line. The ocean is to the right of the buildings. A building has an ocean view if the building can see the ocean without obstructions. Formally, a building has an ocean view if all the buildings to its right have a smaller height. So the ocean is on the right. Return the list of indices, zero index, to buildings that have an ocean view, sorted in increasing order. So we don't care about the buildings themselves. We just want their indices. So let's look at example 1 here. So we have heights equal 4, 2, 3, 1. So the output is 0, 2, 3. So what does this mean? So this is the index. So the 4 obviously is the highest building, so it's going to have an ocean view. The ocean's over here. 2, 0, 1, 2. The 3 will have a view because the only thing to the right of it is the 1. And the 1 will have a view because there's nothing to the right of it obstructing it. Example 2, 4 through 2, 1. So this is all of them because it goes largest to smallest, so they all have a view. And then in the last example, 1, 3, 2, 4, well, 4 is the tallest, so it's obstructing all these other guys. So the output is just index 3. All right, so how are we going to do this? Well, basically, we're going to use a queue, and we're going to add the index. We'll assume that the first building can see the ocean. And then if we come across another building that's higher, then we'll have to take that building out of the queue, the previous building, and stick the new one in there. So we'll start with, so this DQ or deck, however you want to pronounce it, this allows us to pull from the top or the bottom of the stack. We're going to do integer because all we care about are the indices. I'm going to call it stack, and I'm going to instantiate it. Okay, so we got that going. So the first thing we're going to do is take the first integer and assume that it is the tallest. That is a 0, not an O. Okay, so notice, come on, Scott. Okay, notice that this is pushing the 0 index. It's not pushing the first value in heights, it's just pushing the index 0 into the stack. Alright, so now we just need to go through each element in heights. We're going to start with 1 because we already pushed the 0 index into the stack. So it's less than heights length I plus plus. Pretty standard there. Okay. So what we're going to do is basically a while loop, because we need to compare the current building with all the previous buildings. So while the stack is not empty, no sense in going through it if the stack is empty, and height, spell heights sub I is greater than or equal to heights, and this is where we're going to do some fancy stack.peak, which just looks at the top value, doesn't actually do anything with it. So if it's taller than that, then we need to stack.pop. So we need to pop off that. So let's say we have the array is 1, 2, and 3, and we get to 3. Well, 3 is taller than 1 and 2, so we got to, while the stack is not empty and 3 is greater than, 1 or 2, so it's going to keep popping those off. So get rid of all those buildings because 3 is the highest. All right, so now we assume that we have the highest because we popped off all the smaller ones. So now we just need to push this current building, or in this case the index, onto the stack. All right, so this will get us the buildings that have an ocean view, but the order is messed up. So we need to reverse the order here. So we're going to do an int result, and this is going to be a new int of the stack size because we've gone through all of, at this point we've gone through all the buildings, and we have the list in the stack. Okay, and we're going to int equals stack size. All right, so now we need to do for int I equals n minus 1. 0 indexed, I is greater than or equal to 0, and I minus minus. So this will get us through the entire stack. And we just need to do results. So we're going to assign the result equal to stack.pop. So it's going to pop them off in reverse order and give us our answer. And then finally, we're just going to return that result. And that should give us what we're looking for. So let's debug this. All right, so let's debug this. I picked the example, the first example, 4, 2, 3, 1. So the answer should come back building 4, which is index 0, building 3, which is index 2, and building 1, which is index 3. So let's debug this and see what we get. All right, so we're going to push the number 0 into the stack. So we're going to walk through the list of buildings. So we'll height int I equals 1. So we're comparing the 2 with the current height in the stack, which is 4. So it's not, this is not greater. So we're just going to push the 1 onto the stack. Well, now we've got index 2, which is the 3. Well, that is greater than index 2. So we're going to pop, now we have to pop the 2 off. And it's not higher than or greater than 4, so we'll leave 4 in there and push the 3 on there, or index 2. And finally, we've got index 1. Or, I'm sorry, index 3, which is the value 1. So we'll push that on the stack. So now you look down here and you see the stack size is 0, 1, and 2. So we have 3, 2, and 0. Stack size is 3, and we just need to reverse these. So that's what we're going to do. And then pass the result, which is 0, 2, 3. So that's index 0, index 2, and index 3, which is what we expect. So this is the value 4, the value 3, and the value 1. The 3 buildings that have views to the ocean. And actually they're indexes. Or indices. Run this through LeetCode and hope I coded this right. Submit that. Whoops. Well, let's run it first. Sounds like it's going to pass because I already submitted it. Okay, that was it. And submitted. Faster than 25, less than 43% memory. Let's try it again. I always like to do it. Yep, we're getting better. 32 and 51. So let's look at the time and space complexity. The time complexity is O of n, so it just depends on the size of the input. So we're creating a stack. The stack is dependent on the size of heights, the int array heights. If that increases, we're going to increase the time to go through it, all those numbers. And the space complexity, same thing. Where input parameter heights increases, well, it's going to take more space to pop and push all those numbers. And that is it. So thanks again for watching. Let me know if you have questions, and we'll see you next time.